Hello, this is Gary Auden, and I'm bringing you an EDUcast, Big Data in UC Operations. And we're going to be talking about several subjects, as you can see on the screen here. But what we're really talking about is the fact that a network actually has a lot of data that you need to process and analyze. Today with me is Ross Williams, Chief Operating Officer at Virsae. As we do, we talk about what we're going to talk about. We're talking about big data and defining it for the audience here, what it means in unified communications, the challenges you encounter, outages you also have to deal with, why you need a big engine to analyze the stuff, and how automation can help us in this process. Ross, would you expand on this statement as it relates to unified communications management?
Sure, Gary. What we find is that most engineers and administrators understand configuring unified communications platforms pretty well, and they can get the best out of that configuration. What they don't necessarily know is behind the scenes the number of moving parts that need to work together to deliver the outcome that they've configured, and that's pretty much a specialty area.
Would you help us understand what big data is? I've heard so many people use the description and throw it around as if everyone knows exactly what the same thing is.
Well, it can mean different things to different people and different things to different companies. But in our terms, just imagine capturing every piece of data that's related to every interaction you may have within your business. So with internal customers, with external customers, and at an IT level, understanding technically what the quality of that interaction is based on all of that information. So there's a huge number of moving parts that all have to work correctly to produce flawless communication.
Ross, how can we use big data that is collected in the UC environment? What's the value to us?
Okay, well, the big one is, of course, focusing in on customer experience. Did the business process as it was intended, through the likes of call treatment or workflow, did that work exactly as you intended? Has every caller, for example, been informed that the call into the contact center may be recorded? And that's a compliance thing, and that may not necessarily happen. Something may go wrong there. Did the call get to the correct agent in the shortest possible time for an inbound call into a contact center? And and was that call of sufficient quality to enable clear and concise communication between the two parties? From an uptime perspective, a lot of outages are prefaced, if you like, by indicators. They're a precursor to those events, and if you correlate and understand those, you can potentially prevent that outage from happening in the first place rather than reacting to it afterwards. And even better, through technology, automation can introduce, automatic repair steps. Reducing mean time to repair. If you have each and every interaction between those moving parts, if you have all of those monitored and managed at the correct level, you can go straight to the root cause of a problem very, very quickly. In terms of operational efficiency, we can make the human side much more efficient by taking all that information, taking all that data, turning it into knowledge and exposing it to them. And of course, the final step there, detecting fraud. We touched on this on a previous EDUcast where, the SIP world is exposing businesses to risk. And, there's no such thing as an unmanaged firewall in a data environment. There should be no such thing as a unmanaged SBC in a UC world.
We use the word leverage an awful lot. How do we leverage this big data to make UC work a lot better and keep the customer happy?
Traditional applications that UC administrators and engineers have used, simply aren't up to it, Gary. There's a whole new set of tool sets that are required that have the capability and the horsepower to handle big data. And for example, the traditional release cycle around 3 years of sweating an application, things move far, far more quickly nowadays. You've got to have an application that can build and add new features, on a constant basis, just to keep pace.
Big data in the Avaya world has a lot of information. We have this long list of acronyms here. Would you help us with these?
Sure, Gary. These in the Avaya world, these are all sources of big data, and in fact, Virsae uses all of these various methods to pick up and track all those interaction between all of those moving parts.
This slide says challenge of mysterious MG outage. What do you mean by an MG outage, and what's important to us there? Can you dig a little deeper?
Okay, we've got a few examples here of scenarios that I guess engineers would encounter reasonably often, and a lot of people will be able to relate to this, and how we can use big data to resolve these problems. So a situation, as I said, that's quite common. A lot of people recognise you've had a media gateway go down. No one knows why that's gone down, so there's been a business impact, calls have been cut off, business transactions have been lost, and there's kind of a reset. And of course, the business wants a root cause analysis done as to why did that happen, and some sort of permanent corrective action taken. A lot of the times you get into this circle where the voice or the UC people are saying it must be a network issue. The network guys are looking through their logs and so forth and saying, well, there's nothing obvious there, and you sit there at an impasse.
You have a term here called Syslog. It's a display. Would you help us understand its value and what you're talking about?
Yeah, well, relating back to that previous example, we're using an example of the big data that we can access. Within Syslog, when you get that type of scenario occur with a media gateway deregisters within Syslog, there's an immediate trace route run by the technology, and that's captured in Syslog. And you can see in this example here, we've got precisely that type of outage. And within the log, within the text, of course, it does take specialist skill to get access to this and dig it out. But you can see there that in this example, media gateway 51, 80, 50, 40, 2, 110, 90, 170, they all deregistered. And you can see there's a trace route that points the precise point in the network where that issue happened. So the point is that information is there, it's buried within Syslog, but it's absolute, and it does tell you where the source of that problem lays.
We're moving on to SIP trunks, and they're extremely popular today. Take us through the process when there is an outage with a SIP trunk.
A similar sort of thing, Gary, where a lot of the administrators will be able to relate to this. SIP trunk goes down. The voice team get in touch with their carrier. Carrier says everything's okay. Then you get to the point where you're going to need specialist knowledge to try and work out why that SIP trunk's not carrying traffic. And again, as we'll see on the next slide, the data's there if you know where to pick it up.
You have this SM console, has an awful lot of information on the screen. Would you try and explain some of this for us?
Yeah, sure. So again, this is a real-world example, and you can see that we've blurred out some of the names there that might identify the particular customer. But within ECM console, so it's a feature of Session Manager and Avaya technology. Again, those logs are kept. The highlighted text down the bottom there, you can see that trunk group or SIP entity, effectively trunk group has dipped. It's been down between 1804 and 1806. And the cause, so it's a brief outage, it was a couple of minutes, but the cause was definitely at the far end there. There's an error message saying 500 server internal error, destination unreachable. So something went wrong, and it was definitely outside of the customer's technology. It was into the carrier's area.
Let's move on and talk about customer complaints, because especially contact center managers have complaints all the time. Would you take us through the migration process for the contact center manager?
Yeah, so this is another example where people will get asked to get involved from time to time. and a lot of contact centres have a policy that the agents aren't allowed to terminate the call. So they must stay on the call and let the external party terminate. And in this case, the contact centre manager says they've had a complaint that an agent has ended the call. And it is a common occurrence where agents they're being measured for KPIs. They've got to keep their average talk time down and deal with customers within a certain time period. And they're on a long call and they don't want that to affect their stats, so they simply drop the call. So the customers rang back in and said the contact centre agent hung up on them, and the contact centre manager has only got the customer's word for that. They want some absolute proof.
What does ECHI mean, and what is its importance?
Right, the ECHI stands for External Call History Interface. So it's another piece of big data that Virsae picks up and mines. And again, you can see the specialist area there. You really have to know what you're looking at, but we've highlighted the relevant fields and looking for this sort of problem. So we can see the 210 number there. That's originating number. So we can pin that right down to the calling number. We can see the 51038, which is the agent ID that took that call. So we're linking that complaining customer to the particular agent. And then midway across the screen to the right-hand side, there's and amongst all of those delimited text fields, there's the 1, and that 1 indicates that, in fact, the agent did, in fact, release that call. So again, specialist knowledge is needed to understand all this. And also, you've got to be picking these logs up in the first place.
We know there's a huge amount of big data, means massive amounts of data. Why do we also need a large processing capability to deal with all of this?
Well, the logs are simply huge. There's multiple sources. You've got to know where to get the information from. As we saw on the previous slide there, there's an awful lot of places we can go to pick up this big data. We've got to store that in relevant containers. The amount of data is massive, and it does need to be sorted to be in a logical order. And of course, we need a mountain of storage to do all this. So we're talking typically for our customers, hundreds of terabytes. Now to pick that information up, to turn that data and all of those noughts and ones and so forth, and turn that into something that's consumable, we need to have machine learning. Humans just simply can't keep up with the rate of change in this area. Automation, workflows is really critical, so that when this mountain of data is coming in and there's some obvious problems occurring, if we've got automation, we can take some steps to hopefully prevent an outage or prevent a situation from occurring. And then finally, visualization. Humans do need to consume this at the end of the day. We do need dashboards, charts, graphs, and putting all this data into a format that's easily consumed by people.
Would you go a little further about why size matters and the big data processing environment? You've mentioned terabytes. Would you go a little further?
Yeah, there's terabytes of logs that can be picked up and stored, and of course there's the duration of storage too. So some of our customers go with the standard storage, which is 13 months, and there's, as I said, massive amounts of data. We pick up literally billions of database transactions every month. The only way to store that really is store and process that is with cloud applications. The legacy software, enterprise software, really does struggle to cater with such big amounts of information.
Not everyone knows who Virsae is. Would you tell us about Virsae?
We were very early into the cloud, so we ran with the Microsoft Azure right from day one. We mine data automatically. We're always expanding our application, so we run on a 2-week sprint cycle. The stuff that we learned in the previous 2 weeks is put into improvements and rolled out. So our customers enjoy a continuously improving service without having to do anything themselves. We went with an ITIL service management framework. The IoT idea was to take the established IT best practice and apply that to the world of unified comms and contact center, and it lends itself very well to doing that. We do big data analytics and run predictive algorithms, so we're able to predict and prevent outages from looking through all of that big data and invoking workflows and automation.
This slide looks like a flow diagram. Would you help us understand it?
Again, just reverting back to the Avaya World, so this is a typical information flow map for us. You can see up the top left-hand side there that we're a cloud computing service, lives up in Microsoft Azure. So that gives us global reach. So anyone who has an internet connection can consume our service. So our speed of delivery and speed to market is really fast. On site, just across to the right a little, there is a Virsae appliance, which can be a software only or a turnkey hardware device that gets deployed on the customer's network. That's the device that reaches out across the customer's network and talks to all of the applications and servers and endpoints and so forth. Pulls all that information across the network, compresses and encrypts that, and sends that up to the cloud for storage and analytics. So that's our it's typical deployment for us. So the software vendors that we support, not only Avaya but Cisco, Microsoft, Mitel, the usual culprits. In fact, we support some 70 or 80 different vendors.
You know, dashboards are important. Would you go through some of the elements of this dashboard and what it reveals to us?
Right. So as all this big data is streaming into the cloud, we provide real-time dashboards. So these particular dashboards across the top there, they're particular applications. They're kind of built around the OSI model. So at the top we have what's going on at a server level. So we've got the processor, memory, disk utilization, uptime, so forth, including the last sort of 10 minutes of performance. Then as we go through the application layer, so stepping up from the hardware, we look at software services to make sure that they're all running. We run a connectivity test to them, so every device is pinged on a regular basis. All of those pings are stored, so all this information is stored for 13 months. And then we step into like the software service layer and then particulars of each of the applications. So we're getting right into all of the moving parts and monitoring and managing the state of those connections and what's going on all of those parts. So what it really comes down to, with a simple, if a major problem does happen, with a simple glance at a dashboard, you can often see very precisely what the problem is. So engineers don't have to log in and run commands and try and work out what's going on. We're already running those commands for them. So that's all happening through automation. They can simply look at the dashboard to see the output of those commands and go straight to the source of the problem. You know, it really does reduce your mean time to repair in the event you do get a service impacting event.
You mentioned that you keep information for 13 months. How do historic reports benefit us when we're managing UC?
What keeping it historically does for us is a couple of things. So engineers can go back and have a look through this for a root cause analysis. So all this information's there. So for example, if you get a media gateway deregistering or complaining, in fact, about its connection back to its main server, you can see that through reports. You might want to run a report that covers the same time period from a ping perspective, and then you can see, often you'll see that the latency on pings is going out, or in fact there's this complete ping packet loss that lines up, and that sort of information makes it quite absolute and quite clear where the problem lies. The other thing the other benefit we get from this is we're able to trend information. So as we start consuming resources, rather than getting to the point, for example, of running out of licenses and we can't add any more users, if we can trend that information over 13 months, we can start to predict exactly when we are going to need to purchase new licenses. And then we can budget and take that into account for next year.
It's hard to believe that a human can process all this information. When I looked at those screens, the logs and the like, I said, there's so many numbers there, it's very hard for me to understand. How does automation help us deal with big data?
Absolutely, as you've outlined, Gary. People just can't do this. It requires, well, firstly, specialist knowledge. Secondly, the rate of data that's coming in. You'd need teams of specialist engineers to analyze and do this. So what we've done through automation is, if you like, create virtual engineers that sit there and look at all those logs. The virtual engineers we've created, of course, work 24 hours a day, 7 days a week. They don't have vacations, they don't get sick.
Let's complete today, and would you explain the elements of what Virsae offers to deal with these issues?
This screen is our landing page, shows our support for the ITIL service management framework, and that goes to containerizing that data that we touched on earlier, breaking it all down into logical parts for humans to consume. So there's elements of configuration, absolutely underscore how the application is going to perform. And of course, once you understand the configuration of what you're managing, Capacity Manager can step in and can tell you all of your assets, all of your configuration items in ITIL terms, exactly how many are being consumed. Do you have enough in the right locations? Do you need to move some resources down? And of course, it helps you with your budgeting and forecasting when you can see how quickly your various resources are being consumed. Availability Manager focuses on uptime and takes on board that ITIL approach where the end user, their view of the service we're providing is really important. So we zoom in on that. Security management, going around the wheel there, very, very important in this SIP world. Customers' environments are being exposed effectively to the internet in the world of hackers, and we need to know what's going on from that perspective. Change is a good area. A lot of platforms that we manage contain a change log. The problem is the change log's not detailed enough, doesn't go back far enough. Our change manager picks up every change, not only the successful changes, but also failed changes, who made the change, from where and when, what field they changed, what was the old value, what was the new value. Release management, looking across all of your assets and seeing where you stand against what the manufacturers say. And in fact, we do a global benchmark there. So being cloud-based, we look at on an anonymous basis, of course, across the entire world. And then finally down the bottom there, continuity manager, of course. If you need to recover from a major event, Continuity Manager contains everything that you need to do that. So all of your backups, images of what your environment was from a hardware, software, patch, firmware release.
I'd like to point out to people there are a number of EDUcast blogs, papers, videos, and brochures. They're all available at Virsae.com. Select resources. Here's contact information, and one of the nice things is you can actually contact Ross directly, which is not always the case for our EDUcast. So I'd like to thank you, Ross, for today and your enlightening discussion.
It's a pleasure, Gary. Thank you for your time.